See GM VB dash E, you have C, you have LP, this is not LL, it is LP, you have RP, we have R naught, and we have RI. And across RI, I'm going to measure V naught. And you can see now current source, everything is parallel. So again, there is a scope for simplification. Three resistance in parallel, I can simplify them. RP, R naught and RI are in parallel, so I'm taking it as RT. So the parallel combination of RP, R naught and RI, I'm taking it as RT. You know, when resistance is parallel, 1 by RT equal to 1 by R naught plus 1 by RP plus 1 by RI. So if I substitute this simplification in this diagram, finally your output side becomes current source GM BB dash E parallel to one capacitance C, one inductor L, and one resistance RT. And across the parallel combination of all the elements, I measure V naught. So this is the final simplified output diagram, whatever we get for a single tuned amplifier. Any doubt in the derivation so far? Please feel free to ask me. Any doubt if you have. We are just, our goal is to find gain. Gain is V naught by V in. For finding V naught, I'm going to look at the output side. So I need to make my output side very as simple as possible. So we have made all the possible simplification, and we got the simplified output diagram from which I can find V naught easily. Any queries if you have, please ask. I already said this derivation is very, very important from exam point of view. So without skipping any step, if you write, you can easily get into the flow of the derivation. Okay, so now for this circuit, I'm going to find what is the quality factor. So when I told you in the very beginning, the quality factor for a series circuit is X by R, and the quality factor for a components contained in parallel is R by X. So see here, quality factor for this circuit QE is given by R by X. What is the resistance here? RT. So it is RT by X. X can be either the reactance of capacitor or can be the reactance of inductor. So if you take the inductor, R by X, so RT by omega naught L, this term. If you take the reactance of the capacitor, it is RT by 1 by omega naught C. If you take reciprocal, it is RT omega naught C. So this is the final quality factor of the tuned amplifier at the output side. So QE is given by omega naught C into RT, or it is RT by omega naught into L. And finally, output voltage V naught equal to current into impedance minus GM dash E into Z. What is Z? Z is the parallel combination of all these elements in parallel. Okay, so V naught equal to minus, because I measure V naught plus minus like this. So my way of measuring V naught is like this, but you see the current is flowing this way from bottom to top. So the entering node is positive, the leaving node is negative. So V naught is going to be negative. V naught equal to minus GM dash E into Z, where Z is the impedance of all these things in parallel. So whenever components are in parallel, we never find Z, we find Y. Because Y is very easy to find, just take the conductance and add them. And finally, if you reciprocate Y, you will get the value of Z, correct? So remember, whenever you have circuits in parallel, we always find Y. And if you want to find Z, final expression for Y, if you reciprocate, you will get the expression for Z. So you see here, Y is equal to 1 by Z. So 1 by RT plus 1 by j omega L plus j omega C. All the components I have taken the reciprocal. So 1 by RT plus 1 by j omega L plus j omega C. 1 by RT, take it out as common. 1 by RT into 1 plus RT by j omega L plus j omega C into RT. So inside the second term and third term, you multiply and divide by omega naught just to bring Q inside. I want to write the answer in terms of Q. So multiply and divide by omega naught in the second term and third term. Okay, so see here 1 by RT into 1 plus RT into omega naught by j omega L into omega naught plus j omega naught C RT by omega naught. You know that RT by omega naught L is QE, and omega naught C into RT is QE. So wherever you find these terms in the second and third term, these expression I can replace that by Q.